I'm going to be completely transparent here. This is a bit of a rug. I'm not a cryptographer, so everything I'm going to tell you today about ZK circuits and gnark is pretty much the extent of my knowledge. But if you have extra questions at the end, I can always point you towards the right people. But anyways, let's go ahead and get started. We're going to talk about what gnark is. So like starting off, I guess this was my slide to tell you my disclaimer at the beginning. Anyways, what is gnark, right? So this is going to be it's a ZK circuit library. It's a framework for developing SNARKs. So this is actually how we write our circuits at Linea. Oh wait, let me stop. Do we all know what Linea is here? Yes, no? I can't tell. No. Okay, cool. Wow, I just assume everyone knows what I do, but that's false. Okay, so let's start from the beginning, right? So Linea is a ZK rollup. We are a layer 2 bootstrapped by consensus. Right? So what does that mean in a nutshell? Well, for the first part, we're ZK, right? So we are secured by math. We are aiming for a type 2 ZK EVM, meaning we're going for 100% coverage of precompiles, opcodes, all these different things, such that for developers, your experience building on Linea is no different from Ethereum, right? So it looks exactly like the EVM. I think when we talk about bootstrap from the consensus side, that is basically saying we are able to leverage the full power of the consensus ecosystem. And so by that, I mean, like, for example, MetaMask is part of consensus. So there's a lot of areas for synergy between MetaMask and Linea. We are a default network. There's a lot more to come in terms of how it can work together, which is super cool. And then I think the one last thing that I think is really important that people don't realize is Linea is the only multi-client L2 that exists. So it's because of the way we're built. But essentially, if you want to run a node, we can do Geth, we can do Besu, we can do Nethermind. A lot of this is also because Besu, which is a minority client, I think it's the third most common client used, is actually built in-house at Consensus as well. So there's a lot of really cool advantages you get when you have a client team in-house. Alongside just like expertise, you can think of it as 100% support for uptime and things like that. And in a world, if Geth blows up, at least we have other options. But that's Linea in a nutshell. I hope, does that cover everything? Yes? Okay, cool. So anyway, so Linea is a ZK rollup, right? What does that mean? We use ZK proofs to prove that the data that we're posting on Ethereum is correct, right? And how do we do that? We do that in a lot of different ways, which I'll get to in another slide. But today I was going to talk specifically about gnark. So starting over from the beginning, right? So Linea writes its circuits using this open source library called gnark. So what is gnark? So gnark is, I keep saying it's an open source circuit library. There's a few cool things about it. So unlike other kind of circuits, gnark is a Go package. So that means you have no domain-specific language. You get all the benefits of using Golang, like testing, debugging, logging, etc. that you kind of get out of the box. Because of this, you can version your circuits, unit test them, put them in CI/CD workflows, which is really awesome. So it can kind of do everything that you need in terms of like generating proofs and verifying keys. You can use it as a smart contract verifier, ROS16, Plonk, etc. We have the full suite. But actually, I'm going to mention this piece because I get this question a lot. gnark? Okay, well let's roll back, right? So how many of you guys think of ZK proofs and you think privacy? Okay, maybe it's just me. But I get a lot of questions about ZK proofs and privacy, right? So there's a lot of different libraries for writing ZK proofs, like Noir, Circum, etc. gnark is one of them. I would say gnark, the way it's built, is very suitable for performance, right? So when we talk about why we use ZK proofs for rollups, it's because the data that we compress and verify, we want it to be as small as possible, because that is the cost that we're incurring on the L1. So for gnark specifically, it has the property of being able to be incredibly succinct, incredibly fast, right? And so all those are really great for speed and performance reasons. Hi! Sorry, that's my friend. This is Daniel from Scroll, also doing really smart stuff. But regardless, anyways, where was I? Yeah, so gnark is really good for performance-based applications. So I don't know how many people in this room are trying to build rollups. If you are, you will make a lot of money, and you should use gnark, I think is kind of the takeaway here. It's really good for parallelization. and I guess like hardware, right? So when you head to the next slide too, the other thing that gnark offers is actually profiling, which is really interesting for those of you writing circuits. So as you can see right here, this is basically like a graph of all the different pieces that are happening. And like on the Linea side, what we've been able to do with this is note like, hey, a lot of like time, energy, whatever you call it, is being taken place at like the middle part of this, and then that's how we can kind of refine, I guess, the circuit as we move along, right? And to kind of talk about gnark in real life, if you guys know things like ZK8B, ZK Stellar Bridge, other things like we're heavily used. We're actually also using EIP 4844, which is really interesting. But yeah, I guess along those lines too, like I said before, Noir is really great for privacy because they have a JavaScript library, making it very easy to implement. Gnark does not have that feature. However, if you do want to use gnark circuits for a Noir.js like application, you can. But that's beside the point. We're actually going to talk about what it looks like to use a ZK, like a proof in an actual rollup. So this is kind of the process of the Linea prover, right? So first off, kind of going down this line, right? So I don't know what the expertise is. How many of you guys know what like arithmetization and all of this is? Yes? No? Kind of. Okay, so I'll start over. I just made assumptions about everyone and I was wrong completely, so that's completely fine. So basically, in the steps of the prover, right, so this is on the layer 2 side, right, arithmetization, kind of hand waving it away is kind of the process of turning execution traces into like math that the prover can understand, right? Because ZK proofs are ultimately polynomial evaluation. So they are like math words, I guess you could say. And so there's a few ways to do this, right? And with Linea specifically, the way we do it is we have inner and outer proofs that we aggregate together. So what do I mean by that? So kind of in the middle section here, you see a wizard IOP and a lattice proof. So this is actually our first proof that we create. It is, I guess you could say, the thing that sets us apart. Specifically, it's because translating precompiles into, I guess, the math is really difficult. And it's not very snark friendly. So there's a trade-off between, I guess you could say, proofs that are snark friendly versus arithmetization friendly. So for us specifically, we use Wizard IOP, which creates proofs that are actually too big to put on Ethereum, right? So the way we get around it is we use this to basically do the proofs, but we use gnark to prove the correctness of it. Right, so when we're talking about, I guess, like rollups in general, are you guys familiar with like fraud proofs with optimistic rollups? Yes, right? Fraud proofs do not have the same property as ZK proofs, where ZK proofs, they're math. So you can prove proofs of proofs of proofs of proofs of proofs, recursively shrinking them down, proving correctness and other things. So that's actually what we do here, and that gives ZK rollups like a lot more opportunity for scale in the future than you can get with an optimistic rollup, for example. Anyways, so here specifically, like we came up with what we call Alpha V2 maybe like a month ago, and it introduced a few things that I guess like help speed things up, right? The first being proof aggregation, which is basically taking all these different proofs and pulling it together into one, and then the other piece being data compression. So again, like I said, putting that data back onto Ethereum and doing that proof is the most expensive part that you're incurring. So with compression, you make it as small as possible. So what does that look like here specifically, right? So on the top side here, if you look at the top side, I guess, the first yellow box at the, man, I keep saying on top, dude, I'm so out of my element right now, I'm sorry. But anyways, so what we have here is actually the decompression, or sorry, yeah. So we are basically doing a proof of the decompression of the data that is going to be put on Ethereum, right? So that's the top level. You see, we actually also use gnark at the bottom, and that's because the Wizard IOP needs uncompressed data. They cannot take that, they cannot prove that, right? So what we do there is we actually send a proof that we're sending the correct data into the Wizard IOP. It does magic there. And like I said, at the end of it, the Wizard IOP proof is not succinct enough to put on Ethereum. So the next step we have here is actually we prove the correctness of the proof. And that's where the gnark Plonk proof 2 comes in. And at the very end, we have everything together, we prove it all together, and we post it one time to Ethereum. I think I talked around a lot of things. If it didn't make sense, it's okay. It didn't really make sense to me either. All that matters is things are cheap and fast for scaling Ethereum. Unless you actually want to build a rollup, then we can talk about this afterwards. Anyways, why do we use gnark, right? This is actually just, I guess, a few slides for me to shill what gnark is. We actually are the fastest snark out there. So if you look at these different things, I guess over here snarks are faster than snarks, but we aren't using snarks. But anyways, gnark is the fastest snark. I think I wanted to say this, I didn't use the title. gnark actually won the prize for the fastest circuits on mobile. I will say we don't use them actually for mobile because there's additional annoying things that go from using like Go to mobile that don't make sense. But kind of like you can think in a future world, we have the ability to get to that stage. Anyways, so getting started with gnark. I will also say this is a rough because I tried to write a more complex circuit and then I gave up. So we're going to do the most basic circuit there is and cry together afterwards. But anyway, so like this is how basically it works. So the easiest way to get started actually is there's a playground called play.gnark.io, which is pretty fun because it's a playground. And basically the setup of a circuit is essentially we have a struct here, and by default these variables, so this is like your private and your public key. It's by default private, you have to mark it as public, right? And then here, define is actually just where you define the circuit. So in this very simple example, it's basically doing a cubic function. So it's saying, hey, if I multiply these 3 times and add 5, assert that this is true, right? And that's the definition of the circuit. And there are different examples here if you want to get into like more complex situations like RSAs and these different signatures and things like that. But this is like a way to explore the different types of circuit definitions there are there. And you can also like mess around with the code here and then run it. I'll be like, oh, it's wrong. And now it's correct. Cool. So that is basically the way to write a circuit. If you actually want to get into building one and proving it, I have the code right here. Simple circuit tutorial, right? So as in here, when we saw in the playground, right? So we had I think it was a cubic function. This is the structure of it. And then if you actually, the main function, so running it, looks a little bit like this. I'm sorry I'm not live coding because this is a lot that I'm gonna accidentally push, like copy paste incorrectly. But as you can see, you basically just compile the circuit, you can set it up, you can use Plonk or Draw 16, and then you create the witness and then the verification right here. And so in this case, oops, I will go run. Cool, and that is actually saying it's correct. And the really nice thing, like I said, about using Go is you're able to use Golang packages, or Golang testing. So there's actually a test package that we have right here for you. Very simple stuff. You have all the normal like assertion functions here. So prover failed, prover succeeded. And like, oh, those aren't numbers. Right, so if I do Go test, wait, no, why? No, it should not have passed, right? That's, unless I accidentally typed in the correct number, no way. This is so embarrassing. Okay. I need to do. Okay. Cool. I think that failed unless it's telling me my command lines are wrong. Build failed. I don't know what's happening, guys. I don't know.
It's not even working.
Huh?
Maybe you want to add the dash V for logos.
Oh, yeah.
I don't think you're supposed to pass the profile.
Yeah, okay, yeah.
It's not running a simple circuit. It's running a cubic function.
Test, yeah, but this is, it's called test. Wait, why is it failing? Or
Why is it passing?
why is it passing? If I do this one, will it, god damn it. This is proving I'm not AI. Okay, so maybe it's just this one.
Because there's a certain proof of
Oh yeah. Oh, okay, yes, you're
That
right.
makes sense.
It makes total sense. Okay, so if this was 3 and 35, there you go. Then this should fail. Yes. You're right! Woohoo!
Live coding, yes.
Huh? Yes, I can zoom in.
Thanks.
Is it too much? Thank you so much, kind sir. Yeah, so, well, I'm getting hot. Anyways, that is all I have. This is my fault for not writing something more. There is a more complex tutorial if you want to go through it, but I feel like this is unnecessary for understanding how to write a circuit. But yeah, that's the primary way. You just define your public and private keys. In this case, we're verifying the correctness of the EDSA verifier circuit. In the same way, we have different ways of asserting things. So, where was I? What's next for gnark? Are you guys interested in what's coming up on our roadmap?
Sure.
Okay, cool. Well, actually, I'm just going to tell you what happened recently, and then we'll talk about what's coming next. So this is really exciting. Like I said, we worked on proof aggregation recently. The other thing that we're doing is, they're just performance improvements. So proof of decompression, this is the part where I'm talking about specifically the data availability part, where we are able to squeeze it down and post it back. But actually, if you care about what's coming up, again, more aggregation is coming, more compression is coming. It is partially audited, so we expect to see the full audit by summer. And yeah, it's very fast. How many of you guys are hacking in the hackathon? One person. Hey, you! If you're hacking the hackathon, we do have a bounty. You can build whatever you want. I'm judging. I'm very partial to frogs, so hint. Anyways, okay, cool. So that's everything that we have. Here are the docs. If you want to get connected with me specifically, you can join that. This is a chat where a lot of our team is in. So if you have more questions about gnark and everything, they're probably your best bet for talking to the cryptographers specifically. Like I mentioned at the beginning, for all these people who came in later, this is me stretching the boundaries of my knowledge. But I hope all of that sort of made sense. But yeah. Any questions? I hope I conveyed the coolness of it at least. Yes?
You talked about maybe using gnark as a background for noir.
Yeah.
Is that something that's already that we can play with?
Yeah. So not on noir specifically. I think somebody else created their own GitHub where you can build noir.js with gnark circuits in the background. So if you guys use things like Sindri as well, Sindri you can choose between the different types of circuits. So you can choose noir circuits, you can choose circum. Is it circum or circom? I don't know. But yeah. Cool. I hope this was interesting for you guys. If not, don't tell me. Okay, cool. Did you have a question? Yeah.
So when I write circum, I use all these static analysis tools to check my constraints.
Right.
And if we're using gnark as a Go API, do we have any comparative tools?
Yeah, I mean, so I think if you actually run this, you need this, right? You can see all the constraints here. Well, I can do it. I guess we'll call this one. Run it. Oh, what did I do? Yeah. Is this helpful? Is this answering your question? You can like download all and you can see the logs. And you can also debug these.
I was more wondering under tools to check that I'm putting in the right constraints. Under constraint my circuits.
My answer is yes, but my answer is I don't know how to do it. So I will.
I should ask you to do it too.
Yes. Yeah. Cool. Any other questions? Fantastic. We're at 3 minutes. Thank you so much for coming, guys.